unfortunate that we can't have a lesson in class today, so here's how we're going to do it. But before you move on, everyone, have you already completed this assignment as well as this assignment here? Okay? So make sure you're done with page 401, okay? Number 15 through 20 all, and page 402, 36 to 42 all, okay? And then you may move on to this lesson here. Let's go on to this page, okay? Follow along your notes that I handed out to you. Okay? All right. JG says hi. Hey, y'all. Okay? All right, let's go on. So, compose functions. Do you want to make a new function? Function 1 says, let's do it. Function 2 says, and it produces function 3. I have a new function, he says. All right. Function composition is commutative. So, does that mean f of g of x is the same thing as g of f of x? Always? Is that true? So that's what we're going to check for. So we're going to check it with using these two functions, okay? F of x equals x squared and g of x equals x minus 3. Now, we were going to play this game XOXO, but we won't do it. We'll just save it for next time. So we're going to show that function composition is not commutative using 43 and 44. So I want to show you that g of f of negative a and f of g of negative a. Let's see if it is or it is not equal, okay? So we're going to do this sucker first, okay? So that means, remember, we always have to move in and then out, right? So we do f of negative a first. So f of negative a, instead of plugging in x here, we're going to plug in a negative a, right? So negative a squared, we get a squared. A! Now we're going to take this sucker and stick it into g, right? So let's take g. Now we take g of, right? We're going to take g of a squared. And let's see what we get. A squared minus 3. Because instead of an x, we plugged in an a squared. That's what we got, okay? Now, we're going to do number 44 and see if it's the same thing. Now, if they are, then we know that it's commutative. If they're not, then we know it's not commutative. So we do g of negative a first, since that's inside, in to out, okay? When we plug that in, we get a negative minus 3. That's g of negative a. Because we plug, instead of x, we're plugging in negative a. Now, let's go to f of whatever we got for g of negative a. Instead of putting x squared, we're going to put negative a minus 3 squared. And when we do that, it's ugly, but it's a minus 3, negative a minus 3 again. And we get a squared. Now, negative, it's a negative times negative is positive, and positive. That's going to be plus 6a plus 9. And obviously, we see that these are, come on, let's say it. It's not the same thing, okay? That means g of f of negative a is not the same as f of g of negative a, okay? So they're same, but different. You're right, okay? All right, so just know that they are not commutative. Function composition is commutative? I don't think so, not always, okay? All right, let's move on. So I want you guys to go to the next page of your notes. It looks like this. So I have more examples for you. I want to give you these more examples, and then you're going to try some on your own. Okay? So this is number 53 from your textbook. Slightly altered, though. So I want to make it a little bit more interesting. All right? So I have here negative f of x minus g of x. Negative 4 g of x. Okay? Now, we're going to do this using this here. Perform each function operation and then find the domain. So I'm going to do negative f of x minus 4 g of x, okay? All right, so we're going to go negative f of x. F of x is what? 2x plus 5, right? Okay? Minus 4 times g of x, but g of x is here. X squared minus 3x plus 2. Go ahead and simplify that all you want. You'll get something like this. Negative 2x minus 5 minus 4x squared plus 12x minus 8. When you simplify that, you get negative 4x squared plus 10x minus 13. Woohoo! All right? And this one is, what's the domain? All reals. Because think about it. Is there any restriction to x? Is there a value for x that we cannot plug in there? Nope. That's why it's all real numbers. Don't forget the domain, okay? It's going to come really handy later later in the unit, okay? Now, if you want, go ahead and try these two on your own, okay? But all they want you to do is find f of g of x and g of f of x. And we're going to see if they're the same shape or they're not. Okay? And we just proved earlier in the example that they are not. But let's just check anyways, okay? So let's do f of g of x first, okay? So we're going to do g of x first, right? So g of x is x squared. So g of x is equal to x squared. So we're going to take f of g of x, which is x squared, which is every time you see an x, you're going to plug in x squared now. So you get 3x squared, okay? Let's see what we get for g of f of x. Now, whatever f of x basically becomes your domain for g of x, doesn't it? Okay? So let's see if you understand that. So f of x is 3x. Now we take g of 3x. That's our domain now. So now we plug that into g of x, which is 3x squared. We get 9x squared. And watch, are they the same thing? No way, Jose. So we can conclude again, f of g of x is not the same thing as g of f of x, okay? Now, why don't you go ahead and stop the video and try this one on your own, okay? And I'll show it to you. All right, welcome back. How did it go? Let's see if you're right, okay? Was f of g of x equal to the g of f of x? Let's check, okay? So we're going to do f of g of x first, okay? So you can see that g of x becomes f of x's domain. So I'm going to plug in f of g of x, x squared. I skipped a step now, right? So instead of putting just x, I'm going to put x squared plus 5 all over 2. That's the final answer, yeah? So f of g of x, this is our f of g of x, okay? Let's check for g of f of x. So let's see what happens here. So our f of x becomes our g of x's domain. So it's x plus 5 over 2. So instead of putting x, I'm going to put x plus 5 over 2. Square that sucker, okay? Now when I do that, I get x squared plus 10x plus 25. Don't be scared of this. Just write it twice. Divided by 4. And you can again see that these are not the same thing. Okay, so we can conclude. Function composition is not commutative. All right. So you're going to now go ahead and try all the book problems I've assigned. It's on Schoology for you, okay? Now, what we're going to do is this. All I want you to do is think about the situation. You have this paper with you. It's all part of your notes. Now, what if Ms. Chang is feeling so generous and she decides to give the whole class a bonus if everyone passes the next unit test? What usually happens? Ms. Chang says she'll give everyone a 10-point bonus and increase everyone's grade by 9% of their score. What the factor? The ultimate question is this. Would you rather have A, you have choices, okay? 10 points bonus first and then 9%, or B, 9% first and then 10 points. And think about it. Does it matter? Okay. So now f of x says that we're going to get 10 points first. So x, whatever your score is, so x is your score, okay? And we're going to add 10 points. And g of x is 1.09x. So all I want you guys to do is think about this situation, okay? Would you rather have A or B? And also, like, think about what these mean. What does it mean, okay? And this guy too means, okay? All right, think about it, and then we'll discuss it in class. Okay, bye! Enjoy your weekend!